Cool. Well, I just wanted to just introduce myself really quick. I am Laura from Expiro. We're really excited to have all of you today for the JanusGraph User Group Meetup. Just before we get started, just wanted to go over a few housekeeping items, but there will be time for Q&A. So just drop your Q&A questions at the end, at the bottom of your Zoom meeting in the Q&A box, or feel free to chat any of the panelists for questions. We can do them as kind of an open forum if we want to do it after each talk, and then also go back over them at the end. That's great. And then just again, we are recording today's session, so I'll have that. It'll be hosted on Expiro's website and also I believe the JanusGraph website. And I'll send out an email with a copy of the recording for anyone that wishes to have that. Other than that, I don't want to take up too much time from the speakers, so I'll go ahead and pass this over to Ted.
Hey everybody, welcome. Thanks for coming today. Today's our fourth JanusGraph community meetup. If you are new to JanusGraph, first, before we get started, big welcome to you. And of course, any information that you desire to go deeper into some topics beyond what we talked about today can be found at janusgraph.org. And then our latest release can be found up there. And then also, if you're kind of curious about what's coming up in future releases, you can go check out the milestones up on GitHub. Today's kind of theme is going to be JanusGraph and OLAP. And this is not even going to be just particularly probably, solving OLAP with JanusGraph specifically, but in a few of these cases, or at least one of these cases, a discussion of how can we do OLAP using JanusGraph data, but potentially outside of JanusGraph. Because if you've used JanusGraph before and tried to do any OLAP work with Spark, you're probably aware that there can be some challenges with this. So we were interested in finding out what other folks in the community were doing, both in, say, a Spark type situation, and then also just other creative solutions they were finding to work with JanusGraph and OLAP. So we have three great speakers today. Really appreciate them being open to presenting. We have Marc de Lignie, who is also AKA Hadoop Marc. So if you've been active on the JanusGraph user groups or the Tinkerpop Gremlin user groups, I'm pretty sure you probably recognize that name. So we're really lucky to have him. And then Saurabh of Verma from Zeotap, who I think is probably running, I'll go out on a limb here and probably say one of the biggest, if not the largest JanusGraph instance out there. So really excited to hear what they're doing with their production OLAP use cases. And then Bruno Berisso, a compatriot of mine over here at Expiro, who is going to talk about some recent work we did around some real-time analytics use cases in JanusGraph. So with that in mind, I'm going to turn this over to Marc. Actually, one more thing I'll say is, like Laura mentioned, there's going to be some time for questions and answers. I'd ask you to maybe after each speaker, we'll have a few minutes to answer questions specific to the speaker's presentation. If you have general JanusGraph questions, go ahead and just save those for the end, and then we can answer any sorts of general questions you might have. Okay, Marc, I'll turn it over to you.
Okay, now I am unmuted, and now I'm going to try and share my screen. If everything is okay, now you should see my title screen.
Yep, I can see it.
Okay, thank you.
Yeah, no problem.
Okay, Ted Wilmans asked me to give some context to this meetup and just give an overview how users of JanusGraph use OLAP. And I'll present this to you. I'll first give some statistics of threads in the user group, and then I'll try to give an overview in a more condensed form of what kind of obstacles users find on their way when trying to use JanusGraph with OLAP. And I'll conclude with some personal question I have on OLAP. So if there's time for that, I'll present that too. The JanusGraph user group has run, I think, since 2017. All in all, from then since now, more than 1,600 questions, threads, discussions have taken place in the user group. And when you see from the statistics that about 134 of these discussions threads were related to OLAP. Here on the right, you can see from the titles which unique keywords popped up. Then you see that when JanusGraph users talk about OLAP, they really mean using Spark, a Spark graph computer, and also the Tinkerpop Hadoop graph and the related input formats of the JanusGraph distribution to do OLAP. Yeah, you see some specific algorithms also pop up, PageRank, shortest path, but that is rather rare, and most of the users just pop up trying to get OLAP working on their specific system. So when we try to condense all these user questions, there are really three main themes. The first is running on Spark on Yarn, so running it on a large cluster. Sometimes this is also Amazon EMR as a Spark Yarn cluster. There are lots of questions that are related to the input formats of JanusGraph. So that is how JanusGraph presents itself as a Hadoop graph to Spark Graph Computer. And sometimes there are also some questions that are related to getting access to the input Hadoop graph for external algorithms. So if we zoom in on this, when people try to run OLAP on Spark Yarn, you see three other items pop up. First thing, of course, is that the Tinkerpop distribution doesn't include Spark Yarn, and as a result, within JanusGraph, we never decided to include Spark Yarn also. So people have to include this by hand to the dependencies. This is only a minor point. The really big problem when using Spark Yarn is to configure all the environment settings, so getting class paths right for the application manager and executors. And the worst part is getting dependencies right. And this is in particular so when you try to use JanusGraph HBase with OLAP, because many of the HBase dependencies have conflicts with all the dependencies jars that are used by Spark Yarn. So a few years ago, for an older version of JanusGraph, I think that was JanusGraph 0.3, wrote a blog that really sorted this out and described to people how to do this. But this tended not to work anymore for later versions of Spark Yarn. So it's really a headache situation. There are, however, some users on the user list. They described that they didn't use JanusGraph from the Gremlin console, but rather they made their own JanusGraph application, and they basically they made one big jar where they shaded all dependencies related to their application in a brute force manner. And they said that they were able to run a recent version of JanusGraph on Spark Yarn. So this is still something that can be done, but the community never really made this ready to use. So these questions about this keep popping up. On the positive side, in the beginning of the JanusGraph group, there were lots of questions also about using JanusGraph on a standalone Spark cluster. And these questions dried up after there came decent documentation in the JanusGraph reference documentation how to do this. So this shows that it can really be nice to have good documentation on this. And the third minor point that sometimes pops up is that people use the Spark submit shell from their Hadoop cluster, and that can mean that they start adding the wrong Spark version for which JanusGraph is compiled. So that is also not the way to do it. This often pops up. This is the Spark Yarn part. The second main cluster of questions is related to the input formats. And one of the problems with the input formats is that they are not really flexible. They just give the partition size given from the storage backend, they give as Spark partitions. So in particular, this is nasty for HBase because that typically uses partition sizes of 10 or 20 gigabytes uncompressed. So when you try to load this into Spark, this is just not possible for reasonable Spark executor sizes. So that's a no-go there. So the only way that people can use it is to run a snapshot of HBase and do some manual repartitioning and then try to run it. For Cassandra, JanusGraph Cassandra situation is better because Cassandra by default uses something like 256 or sometimes 512 partitions. So you need really large graph before you run into Spark executor memory problems. But we have already seen users that have had that problem. Another thing that keeps popping up with the JanusGraph input formats, that somehow there seems something wrong with the reading performance. So reading of a graph into total Spark memory takes much longer than you would expect. So there seems something strange there. So that would also be nice to, maybe this also returns from the COTAP meeting. So I'll leave it at that. This was not good or very well investigated yet, but we see the questions. The last point, accessing input and output RDDs, that is just something that is not so very well documented in the Tinkerpop reference documents. So most of the time, this is just people giving some hints, and after a while, they found out by themselves how to do this. And I think that is in general, if you want people to help on the JanusGraph user group with OLAP, there is just not, most of the time, there's not just one thing that you can say to people, do that, and then it works. Most of the time, it's just to keep people going, that they try to learn for themselves. And after a while, some of the users, they are persistent enough that they get it working. But it's problematic. Let me see, how long have I talked? It's just 10 minutes. Now then I have a few minutes for my last question. This is not something for the user group, but this is something I wondered from a fundamental point. If you want to do JanusGraph OLAP, and you have some cluster to work on, there is a finite cluster memory. So in general, you can have graphs that are larger than your cluster memory. So if you would running OLAP with the usual traversal vertex program, then you would run into problems, because if you do a query like GV both, at each both step, you are going to have a massive shuffling operation. And if the data doesn't fit into your cluster memory, that means that at each step of the traversal, you get excessive disk spilling, and you can just wait for ages to have a question to your query. So that's a general problem, but I can imagine that there are some use cases that are tractable, and that needn't be use cases using traversal vertex program. That could be any algorithm. So I'm just curious, are there any precautions that you can take that is still possible to do OLAP on such very large graph sizes? And to make this point more clear, I've written down one trivial non-graph example, just to a group by on and do a count on some property from all the vertices. Of course, you could do this in a PostgreSQL very easily, but just imagine you would want to do this also on your graph. Then this is a trivial example that would still work, because there is no shuffling going around for that. So with this, I want to conclude my presentation, and hopefully this gave some context of the current status of OLAP from the perspective of the JanusGraph users. Thanks.
Thanks, Mark. That was a great overview. Yeah, on your last, I think you really highlighted the main issues, which makes me think, what would be kind of like if the community were to, pick up and try to address some of the items, especially from that previous slide, where essentially, users have already found solutions to most of these, at least in isolated cases. Granted, to your point, sometimes there might be, somebody's going to have maybe more than one issue. But what do you think would be kind of if it was going to be like an update to documentation, or maybe providing, say, a Uber jar that's already shaded? What do you think would be like the number one first highest priority item, you think, just to make it easier for folks?
Mm-hmm. Because people have reported success with a Uber jar, some example project just doing that would probably be helpful. Yes.
Mm-hmm. Yeah, that seems like it. Having beat my head against the wall of many times using your blog post, actually, which is super helpful, manually constructing the dependencies and things like that. I was thinking that would be pretty helpful thing to provide. Sorry, I interrupted you. What were you saying, Mark?
No, it's okay.
On the last point about the graph being larger than cluster memory, one thing that I haven't done much with here, and I'm not 100% sure if it should. I'm trying to remember if it should work, but in Tinkerpop, OLAP, you can provide graph filters that should theoretically allow you to only pull some subset of the graph up into the RDDs. Have you ever used that at all? The property or vertex or edge filters? Have you tried that?
I haven't tried that, but that should work for the, yeah, that should limit the shuffling, sure.
Yeah, I've looked, I remember looking at it a while ago, and I'm not 100% sure if JanusGraph had implemented that yet, but not that obviously at some point you're still going to be, low on memory, but I know in some of these other times we've done OLAP work, what we've tried to do is basically just remove absolutely everything that is unnecessary for that, particular OLAP operation. And then that can at least buy you some headroom. So, but at a certain point, if you start spilling to disk, to your point, the performance just becomes, it's unusable. So,
Yes.
so that's a great point. Cool. And anybody have any questions for Marc? Okay. Well, thanks, Marc. Really appreciate it. Saurabh, do you want to kick us off next?
Sure, Ted. Yeah, I'll share my screen. Let's start it. Yeah. Is my screen, is the slide deck visible and moving?
Yep. Looks good.
Awesome. Thanks, guys. So guys, thanks a lot for joining the webinar. And in this talk, I would be presenting the OLAP approaches that ZeoTap is using as of now to work with the graph, data structures and graph DB itself. So let's directly jump into who ZeoTap is. ZeoTap is a customer intelligence and identity resolution tech platform. The mission and vision of ZeoTap is to enable the brands to have 360-degree view of their customers. And ZeoTap is on this path via collecting and specializing, collecting the data of the customers. And this comes into two flavors. One is the profile knowledge about the customers, and second piece is the identity knowledge of the customer. We'll get into that. Some other points about ZeoTap. We might be the largest independent people graph at the moment that we are hosting at ZeoTap. And this I am talking about a native graph DB. There are companies which are hosting even larger graphs, but many of them are not native. And they do some kind of computation on top of that, for example, connected component, and then build a set of use cases or consumption pipelines on top of that. This I'm talking about a native graph DB. We are a Germany, Berlin-based company, and as you know, Europe is heavily focused on the privacy, user privacy, and thus ZeoTap is also fully privacy compliant, and this is incorporated in all the designs that we put into production. Adding to that, you would know that the third-party cookies are going away by 2022. And that's where ZeoTap has also created a universal ID solution called ID Plus. The link is attached here. Yeah. So moving on, what is identity resolution at its core? In the audience that has joined the webinar, each member might be having more than one cell phone. You might be having an IPTV, and you might have signed up for some loyalty program as well. And whenever you interact with the internet via any of these devices, you are identified through an identifier. So if you browse the internet via your web browser, you are identified via a key that is stamped via that particular website. And if you access via mobile, you get something called mobile ID. Identity resolution at its core is unifying or identifying the guy, the user, behind all of these digital touch points. And that is what is shown on this slide. On the right side, we have the digital touch points using which the user interacts with the internet. On the left side is the unified view of the user across these IDs. And if we are able to attach profile attributes to this unified customer, they transitively attach to the digital touch points as well. One unique thing about this use case is that the linkage information is more valuable than the IDs itself, because it is the linkages which builds us this view of the connectedness of the graph. Now, jumping on to the identity graph data model. So this is the data model that we are using as on date in JanusGraph, and we'll spend a few seconds to have a drill down into this. What is this data model? So if you see here, the boxes here represent the digital identities, and the links between these lines between the boxes are the linkages, and this entire graph or the knowledge of connectedness and these IDs is shared to Zeotap via data partners. And these are third-party data partners. They are specialized into collecting the linkage knowledge, and then they share that with Zeotap. Now, if we go within the box, you would see a couple of attributes. For example, we are calling each box has a label called ID. It has some type like it's an online ID. There could be something like offline, which are emails. Then the value of the ID. Of course, we do not store. If you see this example of an email, we do not store the raw. It's for representation purposes. We store only hashed emails. And then there are a couple of other attributes, like what is the device OS for this particular touch point, which country it came from, and which DP it came from. And these are modeled as properties in the JanusGraph. Similarly, edges also have properties. If you see here, we have properties like DP, TS, like which data partner gave this particular link when, some kind of recency metadata. And some of these linkages also have a quality attribute. So this quality attribute signifies the trustworthiness of this particular linkage in the graph. And this information is used while traversing the graph. For example, if we want to identify which all ad IDs are reachable from email, we can reach this ad ID given the quality is higher than 0.5, which is a threshold, and we might not reach this particular Google cookie from this email given the quality of this linkage is not that trustworthy. And these quality scores are scanned via the data science pipelines, which we will just discuss in the presentation. Now, putting some light on the prod setup to set some context that the issues and the approaches that we are having are at which scale. At a very high level, we are using the GCP machines, JanusGraph 052. We are using Scala Enterprise. We are using Google GCP Data Proc, Spark 2.245. Replication factor 3 for the JanusGraph key spaces. For monitoring, we are using the Scala Grafana dashboards. To put some light on the scale, our largest deployment of JanusGraph has 6 nodes of N2-64 and stores around 40 billion vertices and 30 billion edges. And the smallest graph has 3 cross N2-8 machines with RF3 having 3 billion vertices and 2 billion edges. In all, we have around 8 production graphs across regions, and we operate in 3 regions, APAC, US, and the Europe. Moving on specifically to the graph OLAP use cases that we have seen at Zeotap. At the forefront is the reporting on the ID graph. As I mentioned that the data partners keep on sharing data with Zeotap, and that keeps on building our graph. Now, one of the critical business metrics here is that how our graph is evolving with time and which are the most contributing data partner IDs which are sharing this data with us. So which brings the concept of net new IDs that we accumulate periodically and net new linkages per month per country. Additionally, we would also want to see that which data partners are giving us what kind of quality linkages, what is the quality distribution, and this is some kind of lever you can visualize, some kind of lever that tries to make a balance between the scale and accuracy. So if someone says that, okay, I want the number or I want the volume of a graph with quality greater than 0.5, we have certain number. And if someone says that, okay, I want more scale, less accuracy, then he would of course be using a lower quality threshold. And this reporting tells us that what could be the volume for such and such quality thresholds. Of course, quality is a separate topic on its own. And here the classic problem that Zeotap faced and had solved on the way is the supernodes. As I mentioned, the data partners keep on sharing data with Zeotap. And what happens is that these cookies have some kind of TTL values on that. The TTL values are not communicated to Zeotap explicitly from any channel. Thus, we do not know that when to remove an ID from our graph. And because of that, we might have supernodes, because it is just one edge which could link two big clusters in the graph. And I hope that we would be aware of the challenges that supernodes bring. First of all, it is technically really difficult to work with supernodes. Additionally, it leaves a very poor impact or poor reflection of our graph in the market. If you have a supernode which does not represent the real world, it means that the graph is no longer usable. And thus, the supernode detection and cleanup becomes one of the highest priority jobs for us. To list some of the points that are required to assess supernode and the cleanup are the density of the graph, density of the components. And as I mentioned, component here, you would understand that we are not talking about single IDs here. We need to deal with the entire component at once, which lies in the OLAP domain. The depth at which the things are connected, the cluster size and shape, how is it evolving, and the distance at which the connections are happening. Another monetization use case of on top of the identity graph that we have is bulk export of the ID graph. And we do not export our entire graph to the customers for monetization. We export subgraphs and which are based on some kind of client requirement. It could be that, okay, I want all the linkages between email SHA-256 hashes and the Google cookie for Spain, or it could be I want all the linkages for device OS Android. And if you see that none of this lies into the OLTP paradigm of computing, we have to go through the metadata of these IDs and then compute that what is satisfying and what is not, and then export things. So it boils down to the problem of subgraphing and then running analytics on top of the subgraphs. So at a high level, these are the graph OLAP use cases at Zeotap. Moving on to our experience with the JanusGraph OLAP. Of course, when we started working with JanusGraph, our primary use case was OLTP. But one of the POC parameters was also how we can tomorrow run OLAP on top of JanusGraph. And yes, that situation came. And when we tried JanusGraph OLAP, here we summarize some of that experience on these slides. So JanusGraph OLAP is powered by the Tinkerpop OLAP API, and it has a specific class called Spark Graph Computer that allows us to execute vertex programs via Apache Spark. And this is BSP mode of computation, which is essentially a parallel computation mode. The beauty here is that we can run it via Spark. And that's where it looks really promising. Also, SGC by design supports reading from multiple backend stores. It allows us to read data from Cassandra, Scylla, and even HDFS. In order to do so, it has implemented or provides native support for graph-specific adjacency list formats. And here the graph IO format is the recommended one. This is mentioned in the documentation as well. This is all the good things that the JanusGraph OLAP provides out of the box natively. Moving on to our experience with the JanusGraph OLAP on the scale of graphs that we have at Zeotap. We hit a couple of limitations, and the first and foremost limitation there is that there is a mandatory full scan that SGC runs. Whatever be the vertex program, there is a mandatory full scan that Spark Graph Computer runs on the underlying backend. And when we run this full scan on data stores like Scylla, Cassandra, HBase, whatever it be, it is always bounded by the computing power of the Scylla node. It is no longer leveraging the parallelism that Spark is providing us. We are just bounded by the capability of the Scylla or Cassandra. Here we are using Scylla, so I would talk about Scylla specifically. What we identified is that our primary issue is the limited parallelism, where we have an upper limit by the number of token ranges, which Marc was also pointing out, we are using token ranges, or the number of token ranges we are using is 256 for our production clusters. And there is a separate problem for large partitions, which cannot be further broken down into the multiple Spark partitions. So what I essentially mean here is that fundamental unit of parallelism is token ranges, but it is possible that you hit one token range which has a really large partition and that cannot be broken down further. That is by design. And because of the scale of the graphs that we have and limited parallelism, the jobs tend to take a lot of time. In fact, we have never been able to run the OLAP export for any graph. As I have mentioned here, for medium to large size graph, the native approach of SGC has never worked for us. And you know that running such long running jobs on cloud lands into the realm of retries between intermittent node interruptions. This is the primary blocker for us. And here we have to do something. So we'll just get on to that as well. Other limitations that we found are that there is no native support for S3 and GCS. So it requires, it enables or provides interacting with HDFS alone as of now, the packages that are there, and maybe we would have to onboard it with more jars or some code changes required. But the native integration that is given works only with HDFS. And the scale that we have, it is really difficult to store it on a single node HDFS. Third point is that the scan strategy, we know that there has to be a full scan, but the scan strategy is not customizable. So this is especially important for the customers who are using custom vertex assignment, because these guys can always do client-side partitioning. And we can get in details if there are any questions on top of this in the Q&A session. So moving on to the graph OLAP approaches that we are using. As I mentioned that the JanusGraph OLAP has had a couple of blocker limitations, because of which we could not use it in production. And thus, the architecture or the data flow which we landed finally was to not use OLAP on JanusGraph and use JanusGraph only as an OLTP sync. I'll quickly walk through this diagram that we are using as of now in production. So here, if you see these hexagons represent the GCS buckets, wherein we represent the vertex and edge data from the data partners. This goes through an ETL and data science cleanup and scoring pipeline via Spark, and the output is written again on GCS. This is still in the V and E format, vertex and V1, V2 kind of tuple edge format, on top of which we run connected component and create a snapshot, which we are calling as graph at rest snapshot. And our OLAP consumers then run on top of this CC representation of the graph. The cleaned up data, the cleaned up vertex and edges are also loaded into JanusGraph via separate delta ingestion pipeline, and our OLTP consumers consume the JanusGraph for OLTP use cases. So match test was an OLTP use case, and any kind of reporting, analytics, subgraphing, partitioning, all those things are done by the OLAP consumers. There is a compliance pipeline as well, which ensures that all of these stores at rest and the OLTP stores are compliant at all point in times. This is with respect to the GDPR and TCF compliance. So a couple of challenges with V1. If you can see clearly, there are two sources of truth. Our lineup of OLAP consumers and OLTP consumers, it is really difficult to reconcile because both of these stores have diverse states. Why? Because the frequency of the OLAP pipeline and the OLTP ingestion pipeline are different. Secondly, there is a deletion pipeline. This compliance pipeline is essentially a deletion pipeline, which also runs at different frequency. And the kind of updates are also different. In one pipeline, we are doing delta updates, delta deletion and delta ingestion. And in other pipeline, we are doing it at bulk and snapshot level. Now, this creates diverged states of the graph. When I say diverse, what I mean is that the graph at rest and the OLTP graph are in diverse state. They may not be necessarily representing the same set of input data, and then it becomes difficult to reconcile them. And this reconciliation is sometimes also becomes a product requirement, because let's say a new data partner is ingested and we want to assess the impact of this new data partner on OLAP as well as OLTP. We cannot measure that, right? We can just say that, okay, OLAP counts have increased and OLTP match rate have increased, but is the increase justifiable with respect to the input data volume? That is difficult to say if we compare these two consumers. The second point is that the V1 pipeline does not expose a graph in native format for OLAP, and that limits our ability to see into the graph or do any kind of analysis with the graph. And there are many analyses that, as I mentioned, which are required on top of the graph. So this is our existing production setup. And recently we started as the OLAP, the number of OLAP use cases started increasing. We started spending time on the second approach, wherein we have got partial success. Of course, it is work in progress and exploratory. But the high level idea here is that instead of having multiple sources of truth, we ingest all the incoming data to JanusGraph. We do all the deletion on JanusGraph, and then we take the route of SS table and then converting it back to a GRAPH format graph. So that is what we have represented here, that this is the Spark job where all the magic happens, that we are working at Geotap. So the idea at the high level idea here is that we have SS table backup on GCS, and we have implemented Spark jobs that convert the SS table representation of edge store to a graph format. And once we have this, it is returned to GCS, and then it is used by the DS team for scoring and cleanup. And the same output is then written in a consumable format and called native graph at rest. And not, this is not a connected component representation. This is a native graph representation, which is the adjacency list representation. Also, the scores that are generated via the DS pipeline here are written back to the JanusGraph. This is, of course, not yet in production, but planned. That's why it's dotted here. The point to focus or stress upon here is that now in this architecture, there is a single source of truth, and the compute or any kind of analytics that we want to run on the JanusGraph native graph is run via Spark. And this computation is not bounded by the capacity or the partitioning issues of the underlying backend. This data is on GCS, and now we can have n number of Spark partitioning techniques to do better partitioning. That's what I have mentioned here. The approach 2 or V2 provides scalable analytics on native graph. It has a single source of truth, which become eventually consistent. And the current status is that we have been able to do a successful GCS export of the smallest graph at Geotap. With the medium and large size graphs, we are facing issues while decrypting or decoding the incremental Scylla backup and large partitioning handling. For this particular topic, we are in touch with Scylla team, and the work is in progress. But at least it gives us a ray of hope that we might be able to implement the entire OLAP on a native graph via Spark. And that's when I'll conclude my presentations, and we can, if we have time, we can go through some questions as well.
Yeah, thank you so much. We did have a couple questions that came through, which may have been answered throughout, but I'll go ahead and read them, and hopefully we can get them answered. Would it be possible to share or create a repository of the building and config files for successful OLAP configurations, maybe even for different Hadoop services, AWS, Google, Azure, etc.?
Yeah, I think that's a good idea. On that one, I was thinking after ultimately, obviously this being a community project, we need to probably track this somehow. So I'll put a issue in the JanusGraph GitHub for that. I think that's a good idea, and then we will see if we can start collecting some information around that.
Okay, thanks, Ted. Are you using Yarn as your resource manager? If so, which approach do you take successfully implement OLAP with Yarn?
Yeah, we are using Yarn as the resource manager for the V2 approach. That is answered. Currently, SQL implementation is based on the yes, Jen, that's a very valid point. In fact, we at Geotap are also working on the same. My team members are also part of the audience, Shantanu and Vishnu. We are actively working on the migration or a POC that removes or that works with the Spark data stacks connector, which is much more efficient than the existing Hadoop implementation of Spark. What is the size of the graph host? This we have mentioned in the presentation slide deck. This would be there. Do you have any feedback on performance of OLAP use case? So we have not evaluated HBase as of now, and I think this should be HDFS. Yes. So yeah, so we have not yet evaluated HBase. Yeah, that is the current state. So that's why we do not have any insight here as of now. All those identity vertices have different ID properties. When multiple vertices represent the same person, do you assign all such IDs to the person? So the same person will have multiple IDs. Stable ID. So like the way it is modeled as of now is that we have a single stable ID for such a person, which we are internally calling as XUID. But the XUID is not stored in the graph. It is stored outside the graph. The graph only stores the knowledge or the connectivity knowledge of the raw linkages. Yeah, but we do store all of this connectedness knowledge against a singular ID outside the graph. Are you using Spark graphics when ETLing transforming the graph format or just pure Spark algorithms? So here, as of now, we are not using in the V2. We are not using graphics for transforming the Grio as of now. Yeah, but my question is, what is HDFS versus Genus backed by any KV? Yeah. So Vishal, here if we have it on HDFS, I think then we have the power of Spark to achieve any kind of parallelism that we want, right? If you use any KV store, it will, like Cassandra HBase, it will be bounded by the number of token ranges and the large partitions, which I mentioned. So the essence, when you see this slide, the goal here was to bring the data out of this Janus graph backed by Scylla onto GCS, and GCS is equivalent to HDFS, deep storage, and then use Spark to work with GCS and create however number of partitions you want to create. Does that answer your question, Vishal? Okay.
Great, that was great, Saurabh. A really pragmatic and practical approach. I think the thing here, is for folks to keep in mind is if you're already using JanusGraph or you're maybe going to plan on using JanusGraph in the future and you want to do some OLAP work, is depending on your graph size, maybe you can get it to work with Spark without too much trouble, and that's great. But if you can't, there are other solutions that you can use, and don't let yourself be limited to just kind of moving forward with just Tinkerpop OLAP on over the graph right now, because as we've seen, there's some sharp edges still. So might work in some cases, but if it doesn't, like Saurabh's showing here, there's lots of other options. So that was great, Saurabh. Really appreciate it.
Thanks, Ed. Yeah.
Okay, next up we have Bruno.
Hello. Okay. So, hi everyone. I'm Bruno Berisso. I work here on Expiro as a backend engineering. I'm working closely with Ted for the last couple of years, really. So today the idea is to share with you some experience that we have on our recent project and trying to make high performance OLAP queries usable for a final user. So you have interactive OLAP kind of situation. So I will try to dig on the requirements for the case, just let you know a little bit about what we tried with JanusGraph and why it didn't fit this particular case, and how we land on a C++ solution and deploying a microservice in C++. So the use case. We have really two kind of, at the beginning with the project, we have two approaches to the data. First, a big, huge data graph with 6 million kind of vertices and 50 million edges. And another approach was the same graph, but partitioning in many graphs. So we have 700 kind of thing and 6 million edges for the second approach. But the life cycle of the graph were the same. So we have a full reload every day, more or less. The graph was created as a in an ETL pipeline. So the data was spread on a couple of stores. We have Mongo, Postgres, and JanusGraph. And the data was read-only. The data that we were care about was read-only all the time and reloaded every day. The graph was just a standard graph. So the operations that we were working on over the graph were three basic operations. First, the user will need to get a list of shortest paths between two nodes, only following the out edges. And the user can limit the number of hops and the number of results of that list. But the approach was that we shouldn't have a hard limit on the number of hops. That was the key requirement. So the user can ask for 1 hop or 10, and their answer should come on a sub-second fashion. So, and the same for n hops. This is basically a subgraph given a node. The user can have all the graph from that given node, limiting by the number of hops and picking the edge directions. So you have in, out, or both. And of course, you have basic graph navigation, just following the edges and connect to the components. So the project was measure the performance over an HTTP service backend by JanusGraph. We use those two data sets that I mentioned at the beginning. One was the big one and small one. And we built some test scenarios with Gatling. This was provided by the user, so was also a requirement. So we have like 15 currently connected users, 10 running shortest path, 30 running n hops, and then just getting details of a particular node. The idea was to run by an hour and introduce some random pauses over between the requests. But it was a kind of a load test. And the idea was to have sub-seconds response. So let me try to dig on what we try on JanusGraph. The first approach was use JanusGraph plus Scylla. We have a 3-node cluster running JanusGraph with pretty beefy machines. These C5D are 8-core, 3.0 gigs, 16 gigs of RAM, and basically no disk. And for the Scylla node, we have also 3 nodes with 60 gigs of RAM and 30 gigs of SSH disk. So there wasn't a huge cluster, but was big enough. So the measures for Gatling API were pretty bad for shortest path. We just tried with 3 hops, and the mean for the request was really past the seconds. It was around 8 seconds. For n hops, the response were good, but the number of hops were too small to make it valid, a valid test. We tried to increase the number, but the responses were too high. So we just tried with one and got more or less acceptable times. And for the null details, the response was as expected, was pretty good. So the conclusion for the first approach was that it's not good enough for shortest path and hops, mostly because of the number of hops wasn't pretty far from what the client was expected. So the second approach was trying to run the smaller graph with BerkeleyDB on one node. The node is the same as the ones that we use on the Scala cluster. And the results were better, but still far from acceptable. So we have half of the time for shortest path that we had before, but still we were pretty up on the seconds measure for shortest path. For n-hops, results were kind of worse, but still acceptable. But the number of hops was too low for calling a success. And for getting the details was pretty bad. I think that this is because of we were hitting hard on the JanusGraph instance, and that decreased the response times for everything related to the graph. So in this approach, the conclusion was that this one not acceptable either. And so we keep trying a couple of combinations. One was to use only in memory with full Gora, and we have a pretty good approach, results for shortest path. Here we were just trying to improve shortest path because it was the worst case. And we have a pretty good results for 3 hops, but 4 hops were really bad. And with Spark was just not finishing never. So the real conclusion that we have was that probably JanusGraph was not the right choice for this particular case. So we turned to trying to find other approaches. And here is when BoostGraph appears. So first we try with GraphTool. GraphTool is an Python wrapper around C++ core that use BoostGraph under the hood. The performance was pretty amazing. Here we are talking just a graph that fits in memory, but the license was not acceptable for the client. So instead of using GraphTool, we try to think about using BoostGraph directly. BoostGraph, if you're not familiar with, is a library that is part of Boost, C++ library. It's pretty old and pretty stable. So because we have experience on the team on both sides, on our side and the client also, we just give it a try. So the first POC was a command line tool that just grabbed 100 vertices randomly for the data set, for the big data set, the 6 million and 15 million edges, and tried to get a 5-long shortest path between those 2 vertices. And running in my machine, it was pretty good. Was on the sub-seconds response times, and the memory consumption wasn't too big. So we tried to go to the next phase from the POC, and that was pretty smooth also. So fast forward, the client really moved away from the big graph that we discussed at the beginning and was just splitting that big graph in small chunks that can fit in memory. So this approach becomes even more feasible. JanusGraph was still being used for other graph navigations and the other queries, so that stays the same. And transitioning from the client command line tool to microservice was much smoother than we thought, really. So we ended up deploying BoostGraph as an on-demand service on Kubernetes. That was the thing that the client was starting to work on. So once we do that on the first versions of the service running on the cluster, we perform some more measurements with Gatling. Now, the use case that we use were a little smaller. We are not using any of the getting node details because that's not answered by this particular service. That's still being handled by JanusGraph. But the case was using more shortest path queries. So we were running 20 shortest path requests with a random number between 1 and 10 of on the length on the hops, returning all the paths available between those two nodes. We were running 20 n hops requests, limiting by between 1 and 10 the number of hops randomly, and the number of edges returning were between 150 and unlimited. And the data set was a medium-sized data set, and the machine was pretty small. These provides pretty good results. Running, I think that the tests were 20 minutes or 10 minutes, I can't remember now. But the performance was pretty good. For shortest path and for n hops, we were always under the second. So that was acceptable results for this particular case. So we decided that that was the way to go. So I want to just quickly describe how we deployed this on Kubernetes, because for me, I worked in C++ many years ago, and this was kind of amazing to me that the state of C++ was that good, to be honest. We didn't have any bigger problems with anything that you might expect, like memory management or hard to work with on the code base. The things were pretty smooth. So the service was fully functional. We have integration with Prometheus, where some S3 and AWS handling for deploying really and getting the data. We have a REST API really functional. We have logging with log levels and everything. And most of the heavy lifting was done by these open source projects, and that are pretty good. So if you're thinking on taking this kind of approach, I think it's a pretty good approach, to be honest. HTTP is the library that we use for the HTTP server and client, because we were handling authentication also, and works pretty well. We didn't have any problems with that. The AWS C++ SDK is pretty mature. It is being built from the ground up to be performant. So if you need to just consume a big amount of data from S3, for example, it's just made to do that. And also you can use it in small test cases like this. And Prometheus is pretty good also. So if you are thinking on just using any of these, they are all pretty good, pretty mature, and really active. So to finish, let me just show you how we are deploying this right now. This is a quick overview. There are many details here that are not appearing on the slides, but that will take another presentation. So basically, what happening is the user enters the UI and start hitting an API gateway that under the hood hit the controller, and the new instances of Pushkas are started on demand. And this controller also maintains and keeps monitoring the state of unused instances are collected when the user is not using them anymore. An instance can be shared between multiple users, and that works pretty well. Yeah, that's basically the higher level architecture of the solution. We are using Scala on the microservices layer for the API gateway and the controller. There are pretty good libraries for accessing the Kubernetes API from Scala. So the controller was pretty simple to put together. We are using Helm to deploy the new instances. So we can keep control of settings and how the instances are configured without needing to change any code, for example. So this solution is pretty cool. So the conclusion is just, as you can imagine, looking at the picture, is don't be locked on something because you think that it's the thing that you know. Trying to look for the right tool for the job is the right approach. And mostly, as Ted was mentioning, on these kind of situations when you are trying to run OLAP on JanusGraph, seems that you need to be creative pretty quickly if your case is not fitting on the standard cases. And I should mention also that in the looking for the right tool also requires some compromise from the client, mostly because the client is the one that is going to deal with your decisions in the long term. So in this case, we have pretty good luck with the client that was really receptive to having a C++ code base running alongside all the Java stack that they have usually. Second conclusion is that OLAP performances can deliver real-time queries when the graph is not small. Basically, that's what the one that we keep listening today. And the modern C++ is not really bad. I mean, I have a lot of fun really writing that piece of code, and I think that it's going to work for a long time. So that's it for me. Thanks for listening.
Great. Thanks, Bruno. So you could see there is a much smaller graph by orders of magnitude than ZeoTap. And actually, in that case, we were running, it's basically a bunch of subgraphs. Bruno on the previous meetup actually presented on configured graph factory, because for this particular client, each JanusGraph instance is actually hosting maybe up to 100 different graphs. And so I think the salient point there is a lot of times, and Saurabh mentioned this too, I think, or hinted at it, a lot of times a customer end user may want to run some sort of OLAP analytic calculation, or maybe some intense breadth first or depth first search, but they really only need to run it on a subgraph. And so if you can aggressively, pare down the graph, whether it's the total, the whole graph, and you're just only, you're not pulling in all the properties and things like that, or you can just operate on a subgraph, you can make the problem much more tractable. So don't get too caught up if you can't do something on the whole thing, because in many cases you don't even really have to do that. So anyway, it's creativity is the name of the game here. So cool. Anybody have any questions on Bruno's? If not, we can do a few minutes of general Janus Q&A if anybody has any general Janus questions. Okay, great. Well, I appreciate everybody coming today. Like Laura mentioned, we will be posting this recording. So after it's done, I'll get this up on a link to this on the main Janus website, and it'll be up on the Expiro website. And really appreciate the speakers donating their time today, and hope everybody has a good rest of the day.
Yeah, thank you all so much.
Thanks.
Have a great day.
Thanks.